This opening slide lays out the core idea that forensic individuality depends on unique identifiers, data-driven analysis, and careful evidence correlation, with the fingerprint graphic illustrating how microscopic patterns become personal signatures, and how combining measurements and analytics helps investigators link specific traces back to a single source in a scientifically defensible way. Here we trace the evolution of forensic individuality, from 19th century anthropometry to early 20th century firearm comparisons, and finally to modern DNA profiling, showing how advances in measurement precision and scientific methods gradually increased courtroom acceptance and gave investigators more reliable tools for linking evidence to people. This slide explains how random, microscopic events create unreproducible forensic signatures from unique grain structures in tool steel and poor distributions in fingerprints to striation patterns on bullets, and concludes that the complex stochastic processes involved make exact replication impossible, which is why individuality emerges. Everyday use leaves telling marks, as shown by knife-edge abrasion, tire tread erosion, and keyboard wear, and this slide emphasizes that accumulated wear compounds original manufacturing differences into distinct, traceable histories that separate otherwise similar objects through time. Fingerprints rest on biological minutiae that develop early and remain persistent, and this slide connects that permanence to modern AFS technology, explaining how ridge endings, bifurcations, and dots form a stable basis for automated matching and probabilistic calculations that often yield extremely low match probabilities. This slide unpacks how gun barrel striations form through manufacturing tool marks, wear debris and corrosion, how those distinct patterns transfer to bullets, and how examiner analysis can confirm a unique barrel signature, while also rebutting the idea that identical mass production yields identical signatures. Here, we confront the tension between the ideal of absolute individuality and the practical reality of measurable error, noting limits like small population databases and recent black box studies, and describing how validated probabilistic models help shift conclusions from absolute claims to scientifically supported, quantified statements. To ensure reproducibility and reduce cognitive bias, this slide highlights practices like blind verification, standardized nomenclature, and sequential unmasking, and explains how these procedures minimize confirmation effects and produce consistent, verifiable conclusions across analysts and laboratories. This slide shows advanced individualization methods that combine high-resolution data acquisition, such as confocal microscopy, and digital twins with machine learning similarity scoring, and stresses the importance of validating those systems against ground truth datasets to ensure objective, reliable identification. In closing, the presentation reminds us that communicating uniqueness requires balancing the power of distinctive matches with transparent discussion of error rates and context, urging experts to present match findings alongside uncertainties to protect defendants, preserve public trust, and maintain scientific integrity.